Okay, so here we have an example of a differential equation where you need to use the integrating factor to figure it out. These might look kind of ugly at first because you've got this over here. Feels like you might need integration by parts later on. But don't freak out when you see these. Just go ahead and set it up in the form I'm going to show you, and then find the integrating factor, because that usually takes a minute or two if you're good at it, and then you can decide if you want to proceed with this method, because it'll either look really easy or it'll look really terrible. So you need to set it up in this format: y prime plus p of xy equals q of x, and then the integrating factor will equal e to the integral of p of x. Okay, so it actually looks pretty close to that. What we need to do is divide everything by x and subtract this quantity over here, so everything equals this, which will be our q of x. So let's do that. You end up with just y prime minus 3 over xy plus, and that will be, equals x to the 3 tan x. Okay, so we can clearly see that this right here is our p of x. So let's just go ahead and figure out the integrating factor. So it will be e to the integral of negative 3 over x. Well, that equals, this is just, you can move negative 3 outside the integral, so that's just the integral of 1 over x, and that's ln of x. So that gives us e to the negative 3 ln of x. And you can just simply use log properties, because, well, log and exponential properties. So e to an ln is just simply, I think it's just 1. It just goes away. So you can essentially end up with just the x and then negative 3, and anything multiplying a natural log you can put as an exponent. So the integrating factor would then end up being x and negative 3. Okay, so now you need to multiply this right here by the integrating factor. So let's just go ahead and do that. And look, that's why I kept going with this. This cancels out that, so you just get tan x over here. Okay, so that just confirms that we did the right thing. Alright, so now, if you multiply this out right here, it'll be much more clear. But essentially, this quantity ends up being simply y times the integrating factor. And you can figure that out, the derivative of y times the integrating factor. And you can figure that out by just simply doing first times the derivative of the second plus second times the derivative of the first. And you end up with this, just with this multiplied out. So this equals tan of x. So in order to get rid of this, you just simply take the integral. And take integral on the other side as well. These cancel out. So you're left with x to the negative 3 times y. And then, hopefully you remember this because it'll make your life a lot easier, but the integral of tangent of x is simply the negative natural log of cosine of x plus c. So we're given an initial condition. So let's just go ahead and plug that in. So when y is pi over 4, x is pi. Well, multiply these out, you're simply left with pi equals 0 plus c. Therefore c must equal pi, and then we can right finally. This is left in implicit form. You can simply make it explicit by dividing by x to negative 3, but if you do not have to do this, don't, because it's just one more thing you can trip up on, and why bother? If you're not asked to do it, don't do it on a test. At least that is what I say. And there you go. Here's your answer.